Alright, we're going to jump into lesson 13.4, which is on absolute value inequalities. And before we get started, I wanted to just recall a couple of things that we've gone over in the past few weeks. The first one is these compound inequalities, which is something that we've done before. We've looked at these before. We had two types of compound inequalities. We had the AND compound inequalities, and for these compound inequalities, we have our expression set up in between the inequality symbols, and that's because we have to satisfy two constraints here. In this case, x plus 3 has to be less than 4 and greater than negative 4. So we call these types of compound inequalities AND compound inequalities, where our expression is in between our inequality symbol. And the reason that I'm pointing this out is because we're going to start to look at these absolute value inequalities where we have to identify if we have an AND compound inequality or an OR compound inequality. Which brings me to our OR compound inequalities. And for these, remember, it's two separate inequalities. We have x is greater than 4 or x is less than negative 4. So a single number can either satisfy the inequality on the left or the inequality on the right, but not both of them. So these are our OR compound inequalities, and up here we have our AND compound inequalities where the expression is in the middle. So go ahead and take a second, pause the video, and jot this part down if you haven't already done so. And then you can scroll down to these steps. So we're going to move into absolute value and inequalities. So we have both pieces here, absolute value and inequalities. We looked at absolute value equations yesterday, and we were solving those absolute value equations. Now we're adding inequality symbols to that. So we're taking it one step further, and instead of an equal sign, we're going to have inequality symbols. Here are a few steps. You can go ahead and pause the video and jot these down, and then we'll talk about them. Step 1, just like before, when we had the equations, is to isolate the absolute value. So anything that's on the outside of the absolute value, we have to get rid of first. Step 2 is to determine what kind of inequality symbol we have. So we need to look and see if we have a less than or equal to symbol, or a greater than or equal to symbol, because that determines what kind of compound inequality we're going to have. So step 3a says if it's a less than or equal to symbol, that's going to be an AND compound inequality, where our expression will go in the middle. If it's a greater than or equal to symbol, that's going to be an OR compound inequality, where we're going to have two separate inequalities. So these symbols determine if we have an AND or an OR compound inequality. And then after that, we are going to solve. So let's take a look here. So the first one here, if you look at step 1, says to isolate the absolute value. We don't have to do that here because there's nothing on the outside, right? It's just the absolute value of x. So step 2 is to identify what kind of a symbol we have. And in this case, we have a less than symbol. And for the sake of remembering this, we're going to call this a less than symbol. And if you remember from the steps, step 3a says if it's a less than symbol or a less than or equal to, this turns into an AND compound inequality. So we're going to go ahead and turn this into an AND compound inequality. And remember, for those compound inequalities, the variable goes in the middle. And we've got 2 on one side because of the 2 here, and negative 2 on the other side. And then we don't have to do anything else for this one because x is already isolated in the middle there, so we're all done. So the symbol that we have here determines that we have an AND compound inequality. If you scroll down to the next one here, and we look at this symbol, now we have a greater symbol. And remember from step 3b, it says if it's a greater than symbol, that's going to be an OR compound inequality. So this is going to be an OR compound inequality. This one's kind of tricky. So the first part looks the same, x is greater than 2, or set up our second one, x is less than -2. So I'll give you a second to see if you can figure out how I changed that one. So for this one, we flipped the symbol and we flipped the sign. We flipped the symbol and we flipped the sign. And then again, X is already isolated for each one of these, so we're done. Moving to letter C, getting a little bit trickier now. Again, there's nothing on the outside of my absolute value, so I don't need to do any isolating there. I have to take a look at my symbol now. This is a less than symbol. So this turns into an AND compound inequality. So remember, AND compound inequalities, the expression, in this case x plus 2, goes in the middle of our inequality symbols, and we've got 6 on one side because of the 6 here, and we put a -6 on the other side. And then this one does require some solving. So remember, our goal is to get x by itself in the middle there. So we can subtract 2 from all sides, and I get x is less than 4 and greater than -8. Moving to letter D, now we've got to use step 1. We haven't had to use step 1 yet, but for this one we do need to isolate my absolute value. So first I'm going to go ahead and subtract 1. So I get 1/2 absolute value of 3x plus 6 is less than or equal to 3. And then I want to get rid of the 1/2 by multiplying by 2, kind of like a fraction bomb. And so I end up with the absolute value of 3x plus 6 is less than or equal to 6. And now that I've isolated the absolute value, I can go ahead and make that decision. What kind of a symbol do I have, and what kind of a compound inequality am I going to have? This is a less than symbol. So this is going to be an AND compound inequality. And remember, for the AND compound inequalities, the expression goes in the middle. 3x plus 6 goes in the middle. And we have a 6 on one side and a -6 on the other. And now we have to solve for x. So subtract 6. That gives me a 0 on the right and -12 on the left. Then divide by 3. And I get x is less than or equal to 0 and greater than or equal to -4. And once again, that's because we have a less than symbol here that turns it into an AND compound inequality. Moving down to the next one here, nothing on the outside of the absolute value, so I can go ahead and just jump into figuring out what kind of a compound inequality is this going to be. Is this going to be an AND compound inequality or an OR compound inequality? Since we have a greater symbol, this is going to be an OR compound inequality. So for those OR compound inequalities, we set up 2 separate inequalities. The first one looks exactly the same as what I have. The second one, though, we're going to change 2 pieces here. I'll give you a second to look back at letter B to see if you can remember how to do this. We're going to change the inequality sign. So we flip the sign and we flip the symbol. So we make it less than or equal to -6. And now we go ahead and solve this. So I get x is greater than or equal to 2, or x is less than or equal to -10. And we move to the last one here. This one, you can see there is some work to be done in isolating the absolute value. So first I'm going to add 5. And then I need to get rid of the 2 that's being multiplied, so I divide by 2. And I get the absolute value of x minus 3 is greater than 1. And now that it's been isolated, I can go ahead and decide, is this going to be an AND or an OR compound inequality. This is a OR because it's a greater symbol. And for that, we end up with x minus 3 is greater than 1, or x minus 3, I'll give you a second to think about it here, is going to be less than, we flip the symbol and flip the sign, less than negative 1. And then from here, I do need to finish solving, so add 3. X is greater than 4, or adding 3 here, x is less than 2. All right. So just a quick recap. The symbol that we have decides whether it's going to be an OR compound inequality or an AND compound inequality. But this symbol makes that decision for us, right? We have to figure out which one it turns into. All right, thanks for watching.